Sorry about that. Got interrupted. Okay, so we're looking at the difference between this and this. Now I want you to notice that structurally speaking, these are exactly the same. Okay. OH group, CH3, 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 CH3. The only difference between the two is the carbon versus the silicon. Okay. So why the higher boiling point? Well, if we look at our periodic table really quickly, carbon versus silicon, carbon is row 2, silicon is row 3, which means silicon has a larger electron cloud, okay? So our silicon has a larger electron cloud, which is going to create stronger London dispersion forces. So the student claims that Y has a higher boiling point because it has stronger London dispersion forces. That is true. We're going to agree because the larger electron cloud of silicon results in a stronger London force than the carbon. Okay, so that entirely has to do with the mass. Now, are we going to have a little bit of hydrogen bonding from this OH group over here? Sure, but that's going to be true in both of them, so that can't be the significant difference. The significant difference is the fact that over here, in the more nonpolar side of the molecule, we have a much larger central atom, which has a far larger electron cloud, which is going to create stronger London dispersion forces. Okay? All right, and then our last little one says sterling silver is an alloy that is commonly used to make jewelry and consists of 92.5% silver and 7.5% other metals, such as copper by mass. Over time, the alloy can form a tarnish of silver sulfide solid when it reacts with hydrogen sulfide as represented by the following reaction. Okay, we need very little of that to answer this question. The following table contains the atomic radii for silver and copper. So are they similar in size? Okay, silver and copper. Silver has, it's below copper on the periodic table, so it's going to have an additional energy level. So it's going to be a bit on the bigger side, okay? So they're asking us if it's going to be substitutional or interstitial. So let's refresh our memory about what makes something substitutional and what makes something interstitial. Okay. Substitutionary means they're relatively the same size, and so they can serve as a size substitute for one another. Interstitial means that one of them is significantly smaller than the other, and it is able to kind of get in between the atoms and keep it from moving really, really well. In this case, that's not a huge difference. If you looked at the actual side, or the actual size of these, they're not actually all that different. 165 versus 145 is not that different. So this could be considered substitutional. So silver and copper have similar radii, so the alloy would be substitutional. All right. So that's it. Easy peasy.